Hello everyone, my name is Marco Antonio Juarez Tuxpan and my team is formed by Paulina Perez Hernandez and Enrique Rodriguez Correa, and we are gonna present you the family of electric arc welding. I hope you enjoy the presentation, and if you have one question you can ask at the end of presentation, please. The arc welding is one of the most common kinds of welding. The concentrated heat of an electric arc joins metal by pushing the parent metal to a joint using a consumable electrode. Direct or alternating current could be used, and which one depends on the welding material and the electrode. There is different forms of arc electric, such as stick welding. Here is one of the most important types of the arc electric welding, and now we are going to explain each one. Shielded metal arc welding is one of the simplest, oldest, and most versatile welding methods. The arc comes from a coated electrode tip being touched to the workpiece and then withdrawn to maintain the arc. The heat that is generated melts the tip, coating, and base metal, and the weld is formed out of that allow when it solidifies. Slag that is formed that protects the weld from oxides, inclusions, and nitrites has to be removed after every pass. The second type of arc welding, which is very important, is the submerged arc welding. It has a granular flux that is fed into the weld zone that forms a thick layer, completely covering the molten zone and preventing sparks and sputter. It allows for deeper heat penetrations since it acts like a thermal insulator. The process is limited to horizontal welds and used for high-speed sheet or plate sheet welding. It can be semi-automatic or automatic. Third process is also very simple, and as you can see at the picture, I'm gonna explain you. The name is flux cored arc welding. It uses a tubular electrodes that are filled with flux. It's much less brittle than the castings on SMAW electrodes and presents most of the following benefits. It is one of the most important reasons this process is used, because we can solder and alloying metals, and it can save the properties of these metals. Now the next process is named gas tungsten arc welding, and the letters of the process is GTAW. This process is also known as TIG welding. It uses tungsten electrodes at one pole of the arc in order to create the required heat. The gas is argon, helium, or a mixture of those two. Filler wires provide the molten material if it's necessary. This process is good for thin materials, and the filler wires are similar in composition of whatever is being welded. Plasma arc welding is also a very important process, and the letters of this process is PAW. PAW. It has ionized gases and electrodes that generates hot plasma jets that are aimed at the welding area. These jets are extremely hot. The concentration of higher energy is good for a narrower and cheaper weld, as well as an increase in welding speeds. And this process is very useful when you have to do a soldier with a very high speed. And as you can see in the picture, the electric arc is formed by the tungsten electrode and the material. Now we made a comparative table to see the different types of variables that we can control in an arc welding processes. And as you can see in the shielded metal arc welding, one of the most important variable to control is the electrode. The electrode is fundamental to, and the position the electrode is fundamental to the successful welding. Now the flux core arc welding has a very important variable that is the intensity of the current and the volts. And it is very useful because you can do the solder, you can do the welding in a position horizontal and vertical. Now, as you can remember, the submerged arc welding is only for horizontal kind of welding, and the most important variable to control is the speed of movement and the current. It can be direct current and alternative current. In the case of gas tungsten arc welding, we can control the feed rate, which is very important, and the heat input that generates the energy necessary to make the welding. And finally, the plasma arc welding has a lot of variables which we can control. It is the gas flow. I think it is very important because it made the concentration of high energy. As you remember, the diameter of orifice is also very important because it depends the flow of the gas in this case.
Hi, my name is Paulina, and I'm going to talk you about the limitations and advantages of the principal processes of arc welding, and a little bit about the differences between all the processes that exist inside the category of arc welding. Advantages and limitations. First of all, we're going to talk about shielded metal arc welding, or stick as we know it, because it's one of the most common arc welding process that exists. Well, in advantages we have that it has versatility, simplicity, portability, has a low cost, and it is adaptable to confined spaces and suitable for out-of-position welding. In limitations, we have that it's not as productive as continuous wire processes. You have to change frequently the electrode. There is a metal wastage, and the current limits are lower than for continuous or automatic processes. Then we have submerged arc welding, or SAW. In advantages, we have that has high quality welds with minimum operator skills, minimum of welding fume or an arc visibility, suitable to welding thick sections, suitable to welding carbon, low alloy and alloy steels, and high metal deposition rates. And limitations, we have that it's only for flat or horizontal welding. You have to care required to preserve correct electrode alignment, and tip and weld pool are underneath salt flux cover. Other types of arc welding are flux cored arc welding, and it has versatility as a stick and high deposition rates as submerged arc welding. Another advantage is that simplifies training, supervision, and logistics. In limitations, we have that an incorrect selection of consumables and parameters may lead to lower thoughtness, potential lack of fusion type defects, and fume extraction may be required. Gas tungsten arc welding, or TIG as we know it. In advantages, we have that it is applicable to very wide range of materials, especially good for welding thin sections and delicate work pieces, and high quality and appearance welds. In limitations, we have that it's restricted to flat or horizontal welding. As we can see, there are a lot of arc welding processes. We talked about some of them previously, but I want to talk to you about some more of them. For example, in the first image, we have stud arc welding. The second image is for atomic hydrogen welding. The third image is for carbon arc welding. And there is another type of arc welding that it's called bare metal arc welding. And the only difference between this type of welding and stick is the electrode. In stick, the electrode is shielded. Then in the fourth image, we have electro-gas welding. The fifth image is for gas metal arc welding. And finally, in the sixth image, we have magnetically impelled arc welding. Thank you for paying attention, and if you have any doubts, you can ask them at the final for them.
Hello, my name is Enrique Rodriguez, and I'm going to show you two little videos about arc welding.
Shielded arc welding is usually accomplished by means of an electric arc formed between the work and a coated metallic electrode. Let's see what happens. When the arc is struck, it almost instantly creates a temperature of about 6,500 degrees Fahrenheit. This melts both the base metal and the metal in the electrode. The metal from the electrode is melted off in tiny droplets, is carried across the arc and mixed with the molten base metal. The force of the arc and the forward travel of the electrode causes the mixed molten metal to be pushed to the rear of the crater, where it cools to form a bead. The movement of this metal toward the rear of the crater and the depth of the crater are an excellent check on the quality of the work. The operator should learn to use it as his guide. At the same time that the metal is melting, the coating on the electrode is being consumed. This takes place slower than the melting of the electrode, which shields the arc and helps direct the flow of metal. It also permits the use of higher currents, with the resultant faster deposit of weld metal. A gas is formed, covering the arc with a protective shield that prevents the exposure of the molten metal to the air and therefore prevents the formation of harmful oxides and nitrides in the deposit. Also from the coating, chemicals acting as cleansing agents enter into the metal to help to remove the impurities. These chemicals with the impurities float to the top and, cooling, form a coating or slag over the bead. This slag causes the molten metal to cool more slowly and has an annealing effect.
This welding rod fits into an electrode holder, which is insulated and allows the operator to safely hold the electrode without danger of receiving an electric shock. The rod can be positioned in the holder in a number of different ways, depending on operator preference or the position of the work being welded. When the welding machine is on and the ground clip is connected to the steel table or to the work itself, anything metal on this table is now charged. When the electrode makes contact with the work, it completes a circuit. the electricity flowing through the electrode holder, down through the work, and back out through the ground clamp back to the welder. When an arc is struck, a common pool of molten metal is created between the two pieces that are being joined. Into this, the melting alloy center of the welding rod is deposited, completing the weld. One thing to be careful of, as you're welding, this rod is being consumed. That is, it's growing shorter. So that the operator has to constantly be aware of both moving the rod laterally, but also pushing the rod into the seam being welded. The first step in learning how to arc weld is learning how to strike the arc. Striking the arc can sometimes be very difficult at first. It's a delicate flicking motion. It's not a stabbing or a quick drag, but as if you're striking a match gently. Once the arc has started, the trick is to maintain a nice smooth molten puddle of metal with a consistent distance between the tip of the welding rod and the surface of the work. All right, let's give it a try. Welding hoods down. Remember, never look at an arc with the naked eye. Now that you've mastered striking the arc, and it may have taken you several tries, don't be discouraged. Let's join some metal together. Okay, hoods down. After striking the arc, I create a nice even pool of molten metal. You'll notice that the tip of the welding rod stays very near to the arc puddle, and that I'm also slightly wavering the tip of the electrode back and forth. The idea is to heat both pieces of metal evenly as the filler rod is being deposited. Once you've completed your arc welded seam, you'll notice that there's a blue-black residue on top of the weld. This residue is a byproduct of the burning flux. It needs to be cleaned away from the weld. You can do this with a chipping hammer, and wire brush.
Are its applications. Arc welding process may be manual, semi-automatic, or fully automated. In 19th century, arc welding became commercially important in shipbuilding during the Second World War. Today, it remains an important process to the fabrication of steel structure as weldings, vehicles, and other applications.